Well, for the data section, what's really important is that what a calibration curve is using known data to determine unknown data. In this lab, this up here is our known data. Someone else did the lab. They determined the density of a known sugar. This is the density of a known sugar. They also determined the percent sugar in that known sugar. When you make a graph, this should come out to a straight line. This is going to be our calibration curve. So right now we're going to make a calibration curve for a known density. So on the x-axis, we will put percent sugar. Each line is going to be 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The y-axis is going to be density, which is grams per milliliter. And for density, we're going to start with 0.90. The next line is going to be 0.92. This is going to be 0.94. And then this line is 0.96, so this is 0.98. And then the next line is going to be 1. So this line is going to be 1.02. Then we're going to have 1.04, so this is 1.06. And the top is 1.08. And then what we're going to do is we're going to plot each of these values. So first I'm going to do 1% and 1.02. So here's my 1%, and then I'm going to go up to 1.002. So that's going to be right about here, if I made it that. I'm going to put an X there to make it easier to see. And then the next value that I'm going to graph is going to be 5 and 1.008. So if I go to 5 and 1.018, that's going to be right about here, right underneath here. And the next value that I'm going to graph is going to be 10 and 1.038. So if I graph that, that's going to be right about here. The next value that I'm going to graph is going to be 15 and 1.059. And then the last number that I'm going to graph is going to be 20 and 1.081, and that's going to be just above the graph. And then what you want to do is make the best fit line. So we're going to connect these dots just like this. So now this is our calibration curve. We can use a calibration curve to find the percent sugar in our unknown. So if we look at our data, the data that we collected, we can see that one of our densities for Sprite was 1.036. So what we're going to do for Sprite, I will use this color and I'll find 1.036 0.036 is probably around here. And I will connect 1.036 to this black line. And then I'm going to go down. And where I go down, it's not perfect. I'm just going to estimate. I'm going to estimate that that is about 8.7% sugar. 8.7. And then I'm going to do the same thing. And this time I'm going to do it for orange juice. So for orange juice, it's very close. It's 1.037, so it's going to be just above this one. And then it's right over here. It's probably about 8.8% sugar. And then I'll do Gatorade. And for Gatorade, I got 1.096. So that's going to be above this line. So I kind of have to estimate. If I went down, it's probably maybe about 21%. So these values that I just found are my experimental percent sugar based on the calibration that I just found. So this hopefully will help you to find your experimental percent sugar from a known sample of data. Hope that helps.